Okay, in this video, we're going to talk about section 13-2, and it deals with areas of polygons and circles. And in this section, we're going to look at how to calculate the areas of rectangles, parallelograms, triangles, kites, trapezoids, regular polygons, circles, and sectors of circles. And also we'll convert units of area. Okay, so now let's first talk about what area is. Area is measured using square units, and the area of a region is the number of overlapping square units that covers the region. Okay, so sometimes area can be illustrated on something called a geoboard. Okay, and usually a geoboard would just be a board with just dots spread out. Okay, and dots will be in the form of squares. Okay, so let's say we wanted to find out what was the area of this figure, or what is the area of this figure. So pretty much we just have to count the number of squares that we have in this illustration that I'm showing you right here. Okay. So what that means here is we just count the number of squares here. So that's going to be 1, 2, 3, then 4, 5, 6 in this light brown square or rectangle. And then for the purple one, there's 7, 8, 9, 10. Actually, there's actually 4 of these, so we'll add 4 to that. And then for this dark green, 1, 2, 3, and 4. And for this one, 1 and 2. And if there are triangles here, let's see. Oh yeah, there's one more here, so it'll be plus 1. So I got the 6, the 4, the 1, the 4, and the 2. Now, for the ones that have triangles in it, that's half of a square. So 2 triangles make up a whole square. So this triangle and this triangle makes up one whole. This triangle and that triangle also makes up one whole. So if I add all of these numbers together, this will be 10, 14, 16, 17, 18, 19. And it's going to be square units. So in this case here, the area of that figure would be 19 square units. Okay. All right, now the other method is the rectangle method. Now the one that I just did is the addition method. This next one is going to be the rectangle method. Here we construct a rectangle encompassing the entire figure and then subtract the areas of the unshaded regions. Okay, so on the next page, you'll see what that looks like. Okay, so here we have to construct rectangles that encompasses the entire figure and then subtract the areas of those unshaded regions. So here, that area, we have this. And when we, drew the rectangle, here there are 4 going across by 4 going down, that would be 16. And then we subtract off those unshaded areas, like 3, 1, 1, 1, and 1. That adds up to 7. 16 minus 7 would give you 9. So the area of that figure would be 9. Okay. Now let's look at units of area. And mainly just metric units of area is the one that we're going to look at in this section. Okay. So here we're going to talk about converting metric units of area. And the table below shows symbols for metric units of area and their relationship to the square meter. Okay. Now here the basic unit would be the square meter. Here's meter squared. And the relationship for that would just be simply 1 meter squared. Now for the square decameter, that's the symbol for that, but here is going to be 100 square meters. Usually decameters would be 10, but we're squaring it, so it's going to be 100 square meters. And the square hectometer, and here's that symbol for that, and now it's going to be 10,000 square meters. Usually the hectometer represents 100 meters, but when you square it, it's going to be 100 squared or 10,000. And then for the square kilometer, kilometer is usually 1,000. But when we square it, when you square 1,000, that's going to be 1 million. And going back this way, we have the square decimeter. Usually the decimeter is going to be 1/10. Square the 1/10, you'll get 0.01 square meters. Centimeter is 0.01. You square that, it will be 0.0001 square meters for the square centimeter. And then square millimeter, that's usually 1/1000 or 0.001. You square that, you're going to get this 0.000001. Now, converting from one metric unit to another, of area to another, involves moving the decimal point 2 times the number of places to the left or to the right as you would for linear metric units. Okay. This time we're dealing with square metric units. So now it's going to be 2 times the number of places you have to move either to the left or to the right. Okay, and I do have a conversion chart here at the very bottom, as you can see here. Okay, and I created it horizontally from left to right. So now it's going to be 2 times the number of decimal places. Okay, as you would for linear metric units if it was just square, if it was just meters or centimeters or millimeters or kilometers. Now with the square, it's 2 times that. All right, now let's look at this first homework example. Now in this case here, we're going to finish the following conversion table by completing parts A through D. Let's deal with an area of a sheet of paper. And it's 561 square centimeters, 561 square centimeters. And I want to convert that to square meters and also to square millimeters, okay? So let's do this. I'm going to convert from square centimeters to square meters. In this case, using this square centimeters to square meters, we need to move, normally we will move here's square centimeters. Normally we'll move the decimal point 2 places to the left, but since we're dealing with square metric units, it's going to be 2 times the number of moves. So now it's going to be 4 decimal places to the left. Okay, so in the number 561, the decimal point is behind the 1. So that means I need to move this decimal point 1, 2, 3, 4 places. It's always 2 times the number of decimal places as you would for linear measure. Okay, so here this will be 0.0561. 0.0561. And that's going to be in square meters. Excuse me. And then next, we want to convert to square millimeters. square millimeters. In this case here, if we go from centimeters to millimeters, normally we move the decimal point one place to the right, but we're dealing with square metric units. So now it's got to be 2 times 1, or 2 places to the right. So in 561, decimal point is here. Here we're going to move that decimal point 2 places to the right. Okay, so it'll be 1, 2. And then we have to add 2 zeros there. So here, this will be 56,100. Okay, so it'll be 56,100 square millimeters when we convert from 561 square centimeters. Okay, keep in mind it's always 2 times the number of decimal places to the left or to the right as you would for linear metric units. Part B, the area of a cross-section of a dowel. And it's 197 square millimeters. I want to convert that to square meters and then from square centimeters. Let's start with the square centimeters here. In this case here, we're going from square meters, square millimeters to square centimeters. Normally you move the decimal point 1 place to the right, but it's got to be 2 times that. So it'll be 2 times 1, which is 2. So in 197, we need to move the decimal point, which is right here, 2 places to the left. So in this case, it will be 1.97. And that's going to be in square centimeters. Now we're going to go from square millimeters to square meters. In that case, normally using that conversion chart from square millimeters to, well, from millimeters to meters, you normally move the decimal point 1, 2, 3 places to the left, but we got to do 2 times that since it's square metric units. So 2 times 3 will be 6. So here in 1.97, I'm going to move that decimal point, which is right here, 6 places to the left. So it'll be 1, 2, 3, 4, 5, 6. And I need to put 3 zeros in front of the 197. So here I'm going to get 0.000197. I'll put a 0 in front of the decimal point. Okay. And now part C is the area of a desktop. The area of a desktop. Well, it's 1.4 square meters. 1.4 square meters. And I want to convert that to square centimeters and also square millimeters. So in this case here, I'm going from square meters to square centimeters. Okay, square meters to square centimeters. Normally that's 2 places to the right, but 2 times 2 would be 4. So I have to move the decimal point in 1.4, 4 places to the right. So here, we move that decimal point 1, 2, 3, 4. And here I need 3 zeros here. So in square centimeters, it will be 14,000. And then convert 1.4 square meters to square millimeters. Well, from meters to millimeters, that's 3 places to the right. Okay, but since it's in square metric units, it has to be 2 times 3, which is 6. So I'm going to take that 1.4 and move the decimal point this time 6 places to the right. So it's going to be 1, 2, 3, 4, 5, 6. And I'm gonna need 5 zeros here. So this will end up being 1,400,000. 1,400,000 square millimeters. Okay. And part D is the area of a small sign. That's 200 square centimeters. And I want to convert that to square meters. Well, from centimeters to meters, that would be 2 places to the left. For square units, 2 times 2, which is 4. So I'll take the 200 and move that decimal point 4 places to the left. Excuse me, 4 places to the left. So it'll be 1, 2, 3, and 4. And I need a 0 in front. So this will be 0.02. So it'll be 0.02 square meters. And then from centimeters squared to millimeters square, normally from centimeters to millimeters, that's 1 place to the right, but 2 times 1 will be 2 because of the square. So here I'm going to move the decimal point in 200, 2 places to the right. So it end up being 20,000 square millimeters, 20,000 square millimeters. Okay. Again, this is going to take some practice here because you have to remember with a metric unit that's in square units, it's 2 times the number of moves, either to the left or to the right. Okay, now let's go to the English system here. Okay, here the table provides various relationships among unit areas in the English system. Like in this case here, if we have 1 square foot, its equivalent would be 1/9 of a square yard or 144 square inches. Keep in mind, a foot is going to be like 1/3 of a yard. If you square the 1/3, that's 1/3 times itself, you'll get 1/9. And also 1 foot is going to be 12 inches. Well, if you square the 12 inches, you'll get 144 square inches. And then a square yard is going to be equivalent to 9 square feet or 1,296 square inches. Well, a yard, of course, is going to be 3 feet. Square the 3 feet, you'll get 9 square feet. And also 1 yard is actually 36 inches. 1 yard is 36 inches. Square the 36 and you will get, in this case, 1,296. And also 1 square mile would be this, 3,097,600 square yards. And that's because a mile itself is 1,760 yards. Square the 1,760, you'll get 3,097,600. And then 1 square mile is also in feet, 27,878,400 square feet. Because 1 mile is going to be 5,280 feet. Square the 5,280 feet, you'll get 27,878,400 square feet. Okay. Now let's go to land measure. The common unit of land measure in the English system is the acre. For very large land measures in the English system, the square mile is going to be used. And in the metric system, small land areas are measured in terms of a square unit, 10 meters on a side. And that's called an acre. And that is A-R-E, but it's pronounced air. And we denote that with a lowercase a. Larger land areas are measured in hectares. And it's going to be denoted by this, HA. For very large land measures, the square kilometer denoted by kilometer squared is used. Land area measures are summarized in the table below. And actually, that table is on the next page. So in this case here, the unit area, let's say, is 1 acre, and that's going to be equivalent to 100 square meters. 1 hectare is equivalent to 100 acres, or 10,000 square meters, or 1 hectometer, 1 square hectometer. And a square kilometer is going to be 1 million square meters. 1 acre is 4,840 yards. And then 1 square mile is going to be equivalent to 640 acres. Okay. So do be familiar with those equivalents in the English system. Okay. Because we're going to look at a few examples of this, starting with part A. 3,000 square feet is how many square yards? 3,000 square feet is how many square yards? Okay. So in this case here, based on what I'm given here in that problem, I note for a fact that 1 square yard is equivalent to, and I'm going to be dealing with square feet, it'll be 9 square feet. 1 square yard is equal to 9 square feet. So if I want to convert 3,000 square feet to yards, this is what I'll do. I'm converting from square feet, so the square feet goes in the denominator, and I'm converting to square yards, so the square yards goes in the numerator. Okay, 1 square yard means the 1 goes in the numerator. 9 square feet means that the 9 has to go in the denominator. And I'm doing that because I want to divide out the square feet. So here we go. The square feet divides out. You'll be left with square yards. So 3,000 divided by 9. And this is going to be in square yards. So if I do 3,000 divided by 9, and if I do, let's say, the math key, okay, sorry, math key, and I want that as a fraction. That'd be 1,000 over 3, but of course, as a mixed number, this will be 333 1/3 square yards. 333 1/3 square yards. Okay, so they're going to want that as a mixed number or as a mixed fraction. So it'd be 333 1/3 square yards. You just have to divide 9 into 3,000. And then convert the fraction part in simplest form. So that's part A. Part B, 10 to the 9th square yards is equal to how many miles? How many square miles? Wow. Well, let's look at what we have here. Let's find something that's equivalent in a relationship with square miles. I know by looking at this, 1 square mile, that's equivalent to 3,097,600 square yards. Because we got yards and miles. So 1 square mile is going to be this amount, 3,097,600 square yards. So 10 to the 9th, and this is in square yards, that's going to be multiplied by, now I'm converting from square yards, so the square yards go in the denominator, the square miles will have to go in the numerator because that's what I'm converting to. Well, 1 square mile, that goes in the numerator. The 3,097,000, and I'm running out of space here, 600 square yards has to go in the denominator. Okay, and it has to because that way I can divide out the yard square or the square yards. So now I'm gonna have 10 to the 9th, and I'm gonna do this on the calculator here. 10 raised to the 9th divided by 3,097,600. And let's say we want to round that answer to 2 decimal places. So this will be 322.83. And this is in square miles. Okay, 322.83 square miles. All right, now part C is this. 24 square miles is equal to how many acres? Okay, now let's look at what we have here. For every 1 square mile, that's equal to 640 acres. And that's from that table that I just showed you, which is right here. 1 square mile, that's 640 acres. So in this case here, we're going from 24 square miles to acres. So what we're converting from goes in the denominator. We're converting from square miles to acres. So acres has to go in the numerator. Let's see here. 640 acres means that the 640 goes in the numerator, and that's equivalent to 1 square mile. That means the 1 has to go in the denominator. So here the square miles divide out, and all I have is 24 times 640 acres. So if I do 24 times 640, I would get 15,360. Okay, so this will be 15,360 acres. All right. And finally, part D. 5 acres is equal to how many square feet? 5 acres is equal to how many square feet? Well, let's see here. I know that 1 acre is 4,840 square yards, but I want to get to square feet. All right, let's see here. 1 square yard, let's use that. That's equal to 9 square feet. We're gonna have to use both of these here to convert from acres to square feet. You have to go from acres to square yards, and then from square yards to square feet. So here, off to the side, 5 acres. That's gonna be multiplied by, so we're gonna be converting from acres, so that means acres goes in the denominator, and the square yards has to go in the numerator. Well, the square yards has 4,840, that goes in the numerator. 1 acre, that means the 1 goes in the denominator. And what's going to happen here is that your acres will divide out. You'll be left with an amount in square yards, but we want to go to square feet. Well, using the fact that 1 square yard is equal to 9 square feet, here we're going to multiply, and we're converting from square yards, so that means the yard square goes in the denominator, square feet has to go in the numerator. Well, 1 square yard means the 1 goes in the denominator, and 9 square feet goes in the numerator where that square feet is. So now the square yards divides out. You're only left with an answer that's in square feet. So if I do 5 times 4,840 times 9, this will be 217,800 square feet. $217,800 square feet. Okay. So pretty much do be familiar with those 2 tables here with their conversions and be able to convert those from 1 square unit of measure to another square unit of measure. All right, next we're going to look at area, and we're going to look at the area of a rectangle. We'll start off with that. Area of a rectangle. And here, this is just an illustration here where the area of any rectangle will be the length multiplied by the width. So that means if I have a rectangle ABCD with a length of 4 and a width of 3, all we do there is just multiply the length and the width together. So it'll be 4 times 3, which is going to be 12. Okay, so that area would just be 4 times 3, which is in this case 12. And it will be 12 square units because area is always going to be in square units. Okay. All right, next we'll look at this homework example that deals with finding the area. Now, it says here a rectangular field is 20 meters by 19 meters. And here I want to find the area in square meters and in hectares, which is what HA stands for, hectares. So we use the formula for the area of a rectangle, which is, of course, length times width. And I'm going to let this 20 meters be the length. So it'll be 20 meters times the width, 19 meters. And then I multiply 20 times 19. This will be 380. And of course, that's going to be in square meters. So the area of that rectangle or rectangular field would be, in this case, 380 square meters. Now we want this in hectares. So we have to go back to that conversion chart dealing with hectares. And of course, 1 hectare is, now this is in square meters, has to be 10,000 square meters for 1 hectare. Okay. So the fact that 1 hectare is 10,000 square meters. So now for 380 square meters, we want that to go to hectare. That means hectare has to go in the numerator, and we're converting from square meters. That means meter square has to be in the denominator. 1 hectare means the 1 goes here, is equal to 10,000 square meters. 10,000 square meters. That 10,000 has to go in the denominator. So here, the square meters divides out. And then you're going to have 380 divided by 10,000. And that will be, in this case, 0.038. But let's say they want this rounded to 2 decimal places. So here we have to look at the second digit after the decimal point, which is 3. Next to it is an 8. That's bigger than 5, so the 3 will increase to a 4. So it'll be 0.04 hectares. Okay. All right. Another example dealing with the area of a rectangle. Let's say the area of the rectangle to the right is what? And that rectangle has a length of 12 centimeters and a width of 7 centimeters. And I want the area of that. So here the area, of course, is length times width. That means the length will be 12 centimeters times the width, which is 7 centimeters. So here 12 times 7 will be 84, and it's going to be in square centimeters. So the area to the right is 84, and then here they're going to give you a drop-down menu for the choice of answers, which will be 84 square centimeters. Because you got to keep in mind that the area is always going to be in square units. So it has to be square centimeters for this example. Now suppose we had this. Let's say I want to find the cost of carpeting the following rectangular rooms. So in part A, the dimensions of the room are 5.5 meters by 4.5 meters, and the cost is $14.27 per square meter. So in this case here, I need to find out what the area is. So that area will be the length, which is 5 times 5, times the width, which is 4 times 5. Now I'll put the units here as my final answer. So 5 times 5, 5.5 times 4.5. That's 24.75. And this is in square meters. And now we're going to take that $24.75 square meters, because here I want to find the cost. That's 24.75 square meters. That's going to be multiplied by the cost, which is $14.27 per square meter. So if I multiply it like that, what's going to happen here is the square meters divides out. So my answer will be in dollars. So 24.75 times 14.27, that will be, now in this case, I'm going to round this off to 2 decimal places since we're dealing with dollars and cents. Okay, we're dealing with dollars and cents here. So it'd be $353.18. $353.18. Okay, that would be the cost for carpeting that room with the dimensions of 5.5 meters by 4.5 meters. Okay, that's part A. Part B is done the same way. Here we have the dimensions being 15 yards by 12 yards. The cost is $34 per square yard. So if I do find the area first, that will be 15 times 12. 15 times 12 will be 180. So here we're going to have 180 square yards. Okay, and now for the cost. That would be 180 square yards that we're dealing with. That would be multiplied by, in this case, $34 per square yard. So the square yard units divide out. So it'll be 180 times $34. 180 times 34, that would be $6,120. $6,120. Okay. Okay. Let's take a look at this one right here, dealing with a square. Here we got the area of the square to the right, and we want to find out how much that area is. Well, there's a formula for finding the area of a square. And that's this. A is equal to the length of the side and is squared. Okay. And that's because in a square, all four sides are equal in measure. Okay. And the length of that side is 5 centimeters. So if we do 5 centimeters square, we square the 5, that's 5 times 5, that's 25. And then our centimeters will be squared because the area is always in square units. So the area of that square to the right will be 25 square centimeters. Okay. All right, let's look at this homework example number 7. In this case here, Joe uses stuck-on square carpet tiles to cover the 2 meters by 3 meter bathroom. If each tile is 10 centimeters on a side, how many tiles does he need? Well, each side of a tile is 10 centimeters, and he's got a 2 meter by 3 meter bathroom. We need to convert 2 meters to centimeters. And also we need to convert 3 meters into centimeters. I know this, 1 meter is 100 centimeters. So let's use that. The 2 meters will be multiplied by, we're converting from meters, which will be in the denominator, to centimeters, which will be in the numerator. And 1 meter, the one will be on the bottom, is equal to 100 centimeters. That 100 needs to be on top with that appropriate unit. So the meters divide out. 2 times 100 centimeters would be 200 centimeters. So 2 meters is 200 centimeters. And you can pretty much guess what 3 meters is going to be using the same dimensional analysis here. That's going to end up being 300. 300 centimeters. All right. So now to find the area in centimeters, we're going to do the length times the width. That's 200 centimeters times 300 centimeters. So that area there will be 6 with 4 zeros. So that's 60,000 square centimeters for that. And each tile is 10 centimeters on a side. So for that, if it's square tiles, then that means that the area has to be S squared. So 10 centimeters, and you square it will be 100 square centimeters. Okay, because each side is each tile is 10 centimeters on the side. So the area of that single tile is going to be 100 square centimeters. And we want to find out how many tiles does he need? Well, let's divide the 60,000 square centimeters by the 100 square centimeters for each single tile. Of course, the square centimeters divides out. 60,000 divided by 100 will end up being 600. So Joe would need 600 tiles to cover his 2 meter by 3 meter bathroom. Okay. All right, next homework example is this. In part A, if the area of a square is 100 square centimeters, what is its perimeter? Okay, so in this case here, the area of a square, and sometimes it does help to draw the figure. It's not drawn to scale, by the way, but the area is 100 square centimeters. So that means A is equal to S squared, and the area is 100. Now to solve for S, we're squaring it, so the opposite of that would be to take the square root on both sides. And lengths are never going to be negative, so the square root of 100 would just be 10. So the length on each side will be 10. And then the perimeter of that square is 4 times S, because there are 4 equal sides of the same length. So the perimeter of a square is 4 times S. And that length of that side will be 10. So 4 times 10 would end up being 40. 4 times 10 would end up being 40. And it will be 40 centimeters, by the way. Now, part B, the perimeter of the square is 4 centimeters. What is the base? So here we have another square where the perimeter is 4. But of course, the perimeter is always 4 times S for a square. And we're given that the perimeter is 4, so it'll be 4 equaling the 4S. So to find the length of the side, to find out what S is, we divide both sides by 4. So it'll be S is equal to 1. So each side has a length of 1. Now, the area of the square is, of course, S squared, the square of the side. And that side has a length of 1. So in this case here, we square the 1, or 1 times 1, which will be 1. And this is going to be in square centimeters. Okay. So the area of that square will be 1 square centimeter. Okay. All right, next we'll look at another quadrilateral, which is a parallelogram. Okay, so here's what that parallelogram looks like. And when we find the area of the parallelogram, it's going to be the base times the height. So going across at the bottom is going to be the base, and then your height is always going to be perpendicular to the base. So it'll be base times the height. Or if you look at it this way, the base could be this right here, A, the length of A, multiplied by the height that's the segment perpendicular to that base, A times G. Okay, and you want to be careful on identifying which one is the base and which one is the height, because some of the problems may give you more information than you need. Like in the homework example number 9. So let me bring that up. Homework example number 9. Say we have a parallelogram, and I want to find the area of that parallelogram on the right. So here I'm going to be using A is equal to the base times the height. Now keep in mind the base and the height are perpendicular to each other. So you only use those units. So here's your base right here. That's 6 centimeters. So your base is going to be 6 centimeters times the height, which is perpendicular to the base, which is right here. That's going to be 5 centimeters. So 6 times 5 would be 30. And of course, the area is in square units. So that means the area of that parallelogram will be 30 square centimeters. Okay. So that's how we find the area of a parallelogram. Okay, next is the area of a triangle. Okay, now if I take half of a parallelogram, cut it along its diagonal, I will have a triangle. And the area of the triangle, since the area of a parallelogram is the base times the height, the area of a triangle is pretty much half the area of a parallelogram, which is 1/2 the base times height. Okay. So now let's look at a few examples of this one. Let's say I want to find the area. Okay. Now, of course, as you can see here, this one is a parallelogram, by the way. Now, notice here that pretty much this right here is going to be your base, and this will be your height. So here, the base here is going to be, in this case, 5, and the height will be 8. Because this side has the same length as the opposite side in that parallelogram. So the base will be 5, the height would be 8. Okay. So when we find that area, we're just going to do just simply A is equal to the base times the height. So here the base is going to be 5. The height is 8. Okay. So here, if I multiply 5 times 8, that would be 40. And that will be in square centimeters. We don't worry about this 10 centimeters right here. That's just extra information. The same holds true. Well, the 8 is the height, but this 10 centimeters is just extra information that they give you, which is not necessarily needed. Okay. And now let's look at this one right here, where the base is 10. This is a triangle. The base is 10 and the height is 4. So here we have to use the formula for the area of a triangle. A is equal to 1/2 the base times the height. So in this case here, this will be 1/2 the base, which is 10 centimeters, times the height, which is 4 centimeters. So that area will be, well, if I do half of 10, that would be 5. 5 times 4 would be 20. And this will be 20 square centimeters for the area of that triangle. And for this one right here at the bottom, that's another triangle. So we have to use area is equal to 1/2 the base times the height. So here your base is right here. That's 2 centimeters. So this is going to be 1/2 of 2 centimeters times this height, which is 4 centimeters. Well, here, half of 2 is 1. 1 times 4 will be 4. So this will be 4 square centimeters. The area of that triangle would be 4 square centimeters. Okay. All right. Here's a couple of more examples here. Finding the area of triangle ABC in each of the following drawings. So in part A, we have a triangle with a base of 11 and a height of 9. Okay, a base of 11 and the height is 9. So in this case, what we need to do here is just simply take 1/2 the base times the height. So the area is going to be 1/2 the base times the height. So here we got 1/2. The base in this case is 11 centimeters times the height, that's 9 centimeters. Okay. Now, in this case here, if I take half of, let's say 99 square centimeters, that's from 11 times 9, this will end up being 49.5. And that's in square centimeters. And then for part B, you'll have a base of 7 centimeters for this triangle. The height is 6 centimeters. Same thing. Area is equal to 1/2 the base times the height. So here I'm going to take 1/2 of the base, which is 7 centimeters, and the height is 6 centimeters. I can do this. I can take 1/2 of the 6, that would give me 3, and then 3 times this 7 would be 21 square meters. Okay. Let's see, here's one more of these. This one has a radical in it. And I want to find the area of that triangle shown below. Here, the base is, the base here is 8 centimeters, and the height is 4 square roots of 3 centimeters. So again, we do A is equal to 1/2 the base times the height. So this will be 1/2 the base, which is 8 centimeters, and the height is 4 square roots of 3 centimeters. So if I take half of 8, that would be 4. 4 times 4 square root of 3, or 4 times 4 would be 16, and then square roots of 3, and this will be in square centimeters. Okay. Okay. Next, we'll look at the area of a kite. Okay. Now here's what a kite looks like as a geometric figure. And this is what they did here. They took this triangle here, triangle number 1, placed that on top to get this. And then they took this triangle number 4, placed that on top of number 3 to get this. And as you can see here, it's going to be the length of this diagonal times half the second diagonal here. Okay, because this right here is diagonal 2. And this here going across is diagonal number 1. So if we put triangle number 4 on top, what's going to happen here is you're going to have half the second diagonal, which is the area of a kite. Area is equal to 1/2 the length of the first diagonal times the length of the second diagonal. All right, so we're going to use that formula with this example here. So let's say I want to find the area of the kite described below. And we're told that EG is 25.8 inches and FH is 18.7 inches. Okay, so this is EG right here. That's this diagonal. And FH is this diagonal here. So what we'll do here is just take that formula. A is equal to 1/2 D1 times D2. And I'm going to let this be D1 and this one be D2. So 1/2 of D1, that's going to be 25.8 inches times D2. D2 is going to be 18.7 inches. Okay, and I'm going to do this in the calculator. So if I do 1/2 times 25.8 times 18.7, I would get 241.23. And that's going to be in square inches. 241.23 square inches. That would be the area of that kite with those lengths of the diagonals given. Okay. All right. Let's talk about the area of a trapezoid. Area of a trapezoid. Okay. In the area of a trapezoid, it looks like this. Trapezoid has only one pair of parallel sides. It's a quadrilateral with only one pair of parallel sides. Now, the area of that will have to be this: 1/2 the length of the height times the sum of the two bases, the one on the bottom and the one on top. Okay. So in this example here, we're going to use that to find the area of the trapezoid. And in this case, the base on the bottom is 16 centimeters. The base on the top is 12 centimeters. The height is 4 centimeters. So here we use A is equal to 1/2 the height times B1 plus B2. Now, it really doesn't matter which one you let B1 be equal to or which one you let B2 be equal to. So I'm just going to do this, by the way. B1 will be 16 centimeters and B2 will be 12 centimeters. The height is 4 centimeters. So here, that area will be 1/2 of the height, which is 4 centimeters, times B1 will be 16 centimeters, plus B2, that's 12 centimeters. Okay, and I'm going to bring down the 1/2 times 4 centimeters. 16 plus 12 centimeters will be 28 centimeters. And then 1/2 of 4 is 2. 2 times 28 will be 56. And this will be in square centimeters. So the area of this trapezoid described here in this video will be 56 square centimeters. Okay. All right, here's a homework example dealing with the trapezoid. All right, so here the area of the trapezoid to the right is how much? Well, we're given our two bases and the height. Don't worry about that square root of 53 centimeters. That's just additional information that we don't need. All we need are the two bases and the height. So here the area, that's going to be 1/2 the height times B1 plus B2. So it'll be 1/2 the height, which is 7 centimeters in this case. Height goes straight up and down. It's always perpendicular to your two bases, by the way. B1, I'm going to let that be 12 centimeters. And B2, that will be 10 centimeters. I'm going to bring down the 1/2 times 7 centimeters. And then 12 centimeters and 10 centimeters will be 22 centimeters. I'm going to bring the 1/2 down, but I'm going to do 7 times 22. And that would be 154. So it'd be 154 square centimeters since I'm multiplying centimeters times centimeters. And then 1/2 of 54 would be 77. So the area of that trapezoid is 77 square centimeters. Okay. All right, now let's look at the area of a regular polygon. A regular polygon, by the way, is just going to be a polygon where all the angles and all the lengths of the sides are going to be equal in measure. Okay, so to find the area of a regular polygon, it's going to be this. 1/2 the A, and that's going to be this height from the center of the circle or the center of that polygon to a side perpendicular to it, times the number of sides. N is the number of sides, and S is the length of the side. We call that the P, which is your perimeter. Now, the A in this case has a special name called the apothem, APOTHEM. This length is the apothem. That's going to be the height from the center of the polygon to a side perpendicular to it. And of course, your P in this case is the perimeter of that polygon. And you're pretty much going to have to take the length of each side, multiply it by the number of sides. That's where the N times S comes in, which is your perimeter. Okay, so now let's look at this example. Find the area of a regular polygon indicated below. So here, one of the sides of this regular hexagon, and it's a six-sided figure, that's 10 centimeters. The apothem, that's going to be this perpendicular segment here from the center to a point on the side of that hexagon. And that's going to be 5 square roots of 3 centimeters. All right, so here, let's go ahead and find the perimeter first. That perimeter, there's 6 sides, so it'll be 6 times 10 centimeters. That would be 60 centimeters. Our A, which is this perpendicular length right here, that's 5 square roots of 3 centimeters. So here we can find the area. That's going to be 1/2 little a times P. So this will be 1/2. Little a is going to be 5 square roots of 3 times 60. I'll tell you what, I'll just put the units as in my final answer here, but I just want to do the math here first. Let's see. 5 square roots of 3 times 60, I'm going to bring down the 1/2. That would be 300 square roots of 3. Half of 300 is 150. So it'd be 150 square roots of 3. And we're dealing with centimeters, so the area has to be in square centimeters. Okay. So that's how we find the area of a regular polygon. Got to first find out what the perimeter is, and then for the A, that's usually given to you, so you have to use that formula here. All right, now for the area of a circle. Okay, if you recall, a circle is going to be where all the points on that circle have the same distance from a given point called the center. So here's the center, and then the radius is always going to be the line segment from the center of that circle to a point on that circle. The area of that would be equal to pi r squared. Okay, now if you're given the diameter, you have to take half the diameter to get your radius. And sometimes they may ask you to leave the answer in terms of pi or use 3.14 for pi. All right, so on the next page is something like this. The radius of the Earth is approximately 6,378 kilometers. What is the appropriate area of the cross-section of Earth that contains the center of the Earth? Okay. So in this case here, they may ask for your answer to the nearest million. So the radius in this case is 6,378 kilometers. And here it's a circle, so it will be A is equal to pi times the radius squared. And let's say we use, and I think your calculator does have a pi, depending upon what calculator you use. I'm using a TI-84 Plus. It does have pi on it, so that'd be pi times 6,378, and that's going to be squared. Okay. I went ahead and used 3.14 for pi. So let me bring this down, 3.14 times 6,378, and that's squared. And this is what I come up with, 127731695.8. And it's going to be 127,731,695.8. But let's say we wanted to round to the nearest million in this case. That means we need to look at the number that's in the millions place. That's a 7. To the right of that is the other 7. That's bigger than 5. So this 7 will increase to an 8. So this will be approximately 128 million. And the area, well, the radius is in kilometers, so that means the area will have to be in square kilometers. So the approximate area there will be 128 million square kilometers. Okay. All right, next we'll look at the area of a sector. All right, the area of a sector is going to be this shaded area that you see inside the circle. That's just a piece of the circle right here, that shaded area as you see. And it does have the central angle, which is called theta. Central angle is always going to be the angle that's at the, where the vertex is at the center of the circle. And then you have your radius. To find the area, we do theta, which is your angle measured, divided by 360 degrees, times pi r squared. So in this example that I have here, I want to find the area of the sector, and I want to round to 2 decimal places. And I'm going to use 3.14. So I'm going to use this area formula here. So in this case here, let's identify what we have. We do have an angle theta, which is right here, 145 degrees, and a radius of 18 feet. So the area would be theta over 360 degrees times pi r squared. And the angle measured theta is 145 degrees over 360 times pi. I'm going to let 3.14 be pi times a radius, which is 18. And that's going to be squared. Let's see. And we're going to round to 2 decimal places, by the way. What I'm going to do here is this. I'm going to take 145 times 3.14 times 18, and then I'm going to square it. That's all of this in the numerator. And that's going to be divided by my denominator of 360. And hopefully this is right. This will be 409.77. Because I could do this, 145 divided by 360, close parentheses, and then times 3.14 times 18 squared. And I still came up with the same answer. So the 2 decimal places, this will be 409.77, and this is in square feet. So the area there will be in square feet for this answer. So that's how we find the area of a sector using this formula. Okay, the final homework example is this. Heron's formula can be used. Heron's formula can be used to find the area of a triangle if the lengths of the three sides are known. If the lengths of the three sides are A, B, and C units, and the semi-perimeter is S is equal to A plus B plus C divided by 2, then the area of the triangle is given by this formula, the square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C. Here we're going to use Heron's formula to find the areas of the right triangles with the given sides, with the sides given. So in this case here in part A, here we got 5 centimeters, 12 centimeters, and 13 centimeters. So I'll start with that. 5 centimeters, 12 centimeters, 13 centimeters. First of all, let's find the semi-perimeter. And of course, the semi-perimeter is just simply A plus B plus C. That sum is divided by 2. So I have 5, 12, and 13. Those are the lengths of the three sides here. So this will be 5 plus 12 plus 13. That sum is divided by 2. Well, 5 and 12 is 17. 17 plus 13 is 30. 30 divided by 2 is 15. So the semi-perimeter is 15. Okay. So the area of the triangle, I'm going to label that as A. That's going to be equal to the square root of S times S minus the first length times S minus the second length times S minus the third length. Okay, so in this case here, that 5 would be A, the 12 will be B, 13 will be C. And I'm going to substitute into this formula, Heron's formula. So the area will be the square root of S, which is 15, times S minus A, that's 15 minus A, which is 5, times 15 minus B, which is 12, times 15 minus C, which is 13. So in this case here, all of this would be under the square root. Bring down the 15 and do 15 minus 5, that's 10. And then 15 minus 12, that's 3. And then 15 minus 13, that's 2. Then we're going to multiply what's underneath that, radical. If I do 15 times 10 times 3 times 2, 15 times 10 times 3 times 2 will be 900. And if I take the square root of 900, this will be, it'll be 30. So the area of that right triangle will be 30. And it's going to be 30 square centimeters. 30 square centimeters. Okay, that's Heron's point. That's how we apply Heron's formula to find the area of those right triangles. So that's part A. So here I'm going to do part B. We have 9 centimeters, 40 centimeters, 41 centimeters. And here I want to find the area of that triangle. First of all, let's find the semi-perimeter, which is, of course, A plus B plus C, all divided by 2. So here your A is going to be 9, B is 40, and C is going to be 41. So you have 9 plus 40 plus 41 divided by 2. Let's see, 9 and 40 is 49. plus 41 will be 90. 90 divided by 2 is 45. So the semi-perimeter will be 45. And then we use our formula, well, the Huron's formula. A is equal to the square root of S times S minus A times S minus B times S minus C. Okay. So in this case here, your A is going to be 9, B will be 40, and C will be 41. Okay, sorry about that. And in this case here, A is equal to the square root of S, which is 45, times S minus A, that's going to be 45 minus 9, times S minus B, that will be 45 minus 40, and then S minus C will be 41 minus 40. 45 minus 40. Because S is 45. And C is 41. So that's all wrong right there. 45 minus 41. So here A is equal to the square root of, break down the 45. 45 minus 9 will be 36, times 45 minus 40 will be 5, times 45 minus 41 will be 4. So the square root of, I have to do 45 times 36 times 5 times 4. That would give me 32,400. And if I take the square root of 32,400, I would get 180. So the area of that triangle with the lengths of 9 centimeters, 40 centimeters, and 41 centimeters will be 180, and this will be in square centimeters. Okay. All right, so that's how we apply Huron's formula to find the area of those right triangles in this case. Okay, so that does conclude this video on section 13-2, dealing with area of polygons and circles. Feel free to contact me if you have any questions about anything presented in this video, or if you have any questions about the homework in my math lab for this section.